Hello, and welcome to a review and some new stuff too. We're going to be looking at some concepts that will hopefully refresh you on some things that you've already learned about in terms of research methods and statistics. Before we go any further, take a look at the syllabus, look at the review sheet in the syllabus, and try to answer as many questions as you can. And then we'll go forward and talk about each of these concepts. So you can just pause this presentation, fill that out, and then come right back to it and listen to my lovely voice. Okay, scales of measurement. Recall that we discussed 4 types of scales. Remember that nominal scales were classified or categorical. And sometimes we call nominal variables categorical variables. We also call them discrete variables. And they're variables like sex, ethnicity, religion. These are variables that we categorize. So even if we say males are 1 and females are 2, that doesn't mean that one value is greater than another value. It's just a way of creating a variable. Ordinal variables are often referred to as discrete variables because they represent categories, but there's an order to the categories, such as being in a race. First place, second place, third place, or most liked to least liked. But despite there being an order, we don't know the distance between the values. For example, I may know that one student performed higher than another student, but I don't know the degree to which those students were different. They may have been really close, they may have been very spread out. We don't know that. Now, an interval scale also has an order to it, like ordinal, and we do know the value, so we can say that, yes, this student appears to be more depressed than another student. And we can look at scores on the BDI-2 and we can see a value that one student was 3 points higher on the Beck's Depression Inventory 2 than another student. A ratio scale means that there's a true zero. For example, when you take the BDI-2, a zero doesn't necessarily mean an absence of depression. It's an interval scale. But a ratio scale does imply a true zero. So an absence of something. How many drinks did you have today? I had 0 drinks. Hence, that is a ratio scale. And remember, that we talked about interval and ratio scales being continuous values, values that you can add, subtract, multiply, divide, create means and standard deviations from. So variables are either discrete or continuous. Also, recall that we talked about this type of value that is quasi-interval, like on a Likert type scale. 5 is strongly agree and 1 is strongly disagree, and then 2, 3, and 4 represent values in between. And we use those scales and we create means and standard deviations from those scales, so we treat those values as continuous data. But the way that somebody says, well, this happens, I strongly agree with this comment, for example, the fact that one student answers a 5 maybe versus a 4, that value could be different for another student, so or client. So there is some subjectivity between the difference between a 4 and a 5 for each individual, but we treat those scores like there's not. So that's quasi-interval. What does statistically significant mean? Remember that statistical significance is a term about probability. It is the likelihood of an event occurring outside the realm of chance. So if we were to do a study, the likelihood of getting that result, out of 100 times, let's say, if I say an alpha level of 0.05, I'm setting up 95% confidence in those results, which means 95 times out of 100 with similar data, we'd get the same result. So just to kind of reiterate, an alpha level is one way that we can convey that that percent of probability of something being correct or confidence or occurring again. Not necessarily correct, but occurring again. When I see p is less than 0.05, what I'm saying is that there's a greater than 95% chance that I could replicate these results with a similar sample. Type 1 error. Remember, we can say that the null hypothesis is either rejected, and then some folks like to say, or fail to reject the null. And remember, I don't like those terms of double negatives. We either reject the null or we retain the null. So when we say that we've rejected the null, we've also said that there was a statistically significant relationship. When we retain the null, we're saying that there was no statistically significant relationship or difference. So we denote the amount of type 1 error by setting an alpha level. So whenever I set an alpha level of 0.05, I'm allowing a 5% chance of making a type 1 error. Hence, as alpha goes up, 0.10, for example, I'm allowing a 10% chance of type 1 error. I'm increasing the likelihood of making a type 1 error. As I decrease my alpha level to 0.01 or 0.001, I'm decreasing the likelihood I'm going to make a type 1 error. So, and just kind of keep in mind that we can make a type 1 error if our sample isn't representative or if we have poor methodology. All those things can contribute to making a type 1 error. A type 2 error is that I retained the null when I should have rejected it. In other words, I said there were no differences when there actually were. Type 2 errors happen when sample sizes are insufficient, or if I use an overly conservative alpha level. I'm not finding statistical significance at 0.001, but I might have at 0.05. So what do you think is more problematic, type 1 error or type 2 error? Well, it depends. Would it be worse to give a class an intervention that wasn't effective? All right, so I think this intervention is going to be effective, but it's not. That's a type 1 error. Or would it be worse to withhold an intervention that would be effective? Type 2 error. This would have made a meaningful difference, but I didn't provide it. What is practical significance? Remember that practical significance refers to the meaningfulness of your finding and is often referred to an effect size, like Cohen's D was one type of effect size that we used with our t-tests. And there is a difference between statistical and practical significance. Statistical significance does not address meaningfulness. Remember, it's a term about probability, whereas practical significance does not address the probability of obtaining results. It's just talking about the magnitude of the effect. So how big the differences were, or how small the differences were. Hence, you can find a statistically significant result but not have a meaningful effect. What about power? The likelihood of rejecting the null when it should be rejected is power. In other words, it's the likelihood of finding a statistically significant difference or relationship given that such a relationship actually exists. So we refer to power statistically as 1 minus beta, and an acceptable level of power in social science research is 0.80. Now that means that if I'm likely to find statistical power at if I find that it's adequate at 0.80, what that also means is that if there's an 80% chance that I'm going to find a statistically significant relationship if it actually exists, that also means I'm allowing a 20% chance of type 2 error. Now I can control that by having a large sample size, and we'll be talking about that this semester as we discuss on how to evaluate statistical power. Okay, that concludes a lecture of a review and some new stuff too, and I hope that this was helpful.